Hello friends and welcome at my channel. Last time we've been talking about tangents and sines and cosine functions and their relationships, and now I would like to show you how to compute a sine of sum and a sine of a difference. So basically we're deriving now in this video 4 formulas. The first one is sine of alpha plus beta is equal to sine of alpha cosine of beta plus sine of beta cosine of alpha. That's the first one. The second one is sine of alpha minus beta. This is sine alpha cosine beta minus now sine beta cosine alpha. The third one is cosine of alpha minus beta, or let's start with plus. This is going to be cosine alpha cosine beta minus sine of alpha times sine of beta. So kind of contraintuitive, as you can see, because in the first two cases, well, there is plus between the angles and plus between the terms later on. So this plus is somehow corresponding to this one, but with the cosine it's different. So which once again tells us don't memorize, try to get it. And cosine of alpha minus beta is now cosine alpha cosine beta plus sine alpha sine beta. So how to prove it? Well, the idea is we firstly prove it geometrically, and then we'll see how it works. Okay, the first formula we prove it geometrically, and then we'll use it, and I don't gonna need any geometry further. I'm gonna prove the second, the third, and the fourth formula easily. All right, so let us remember that if we have a parallelogram which looks like that, we have A and B and the angle phi between of those two. We can also put a height going down, which we call h, and you see if you kind of cut off this triangle and put it exactly here, you will get a rectangle with the same area that the parallelogram had. So that means we are having here A times H, but at the same time, if you look at this right angle triangle, you see that H divided over B, this is the sine of phi. So that means H is equal to B times the sine of phi. So I can substitute H through B times the sine of phi this way, and A of course in front. So the formula is for the area of parallelogram. All right, but now let's also see that if we have a whatever triangle, so an arbitrary triangle with A, B, and C, and some angle gamma in between, we can add exactly the same triangle in here, like this. And this triangle, added up to the first one, is giving us a perfect parallelogram. Well, the area of the parallelogram, we can compute it, right? It's AB times sine of angle in between. And now we're talking about the area of just only single triangle. So A of a triangle, area of a triangle would be a half A, in this case C I called it, and then the sine of gamma. All right, so that's the story. That means the area of a triangle is just a product of A times C times the sine of the angle in between. Simple as that. All right, let's move on. Let's see what's happening next. Well, let us produce such a triangle. We're not asking for anything, okay? So it's just an arbitrary triangle with A, B, and C. Let's put a height like this. So this is H, twice 90 degrees. And we're subdividing our C into two pieces, P and Q, right there, okay? So how could we compute the area of this triangle? Well, let me also call it maybe gamma, and this one phi. Okay. Now let's see. What is the area of this triangle? Well, first of all, I can take the formula I derived here. So the area of the whole triangle, it's a half a times b times the sine of the angle in between. But the angle in between consists of two different angles, phi and gamma, so this is the sum of phi and gamma. That's the story, on the one hand. On the other hand, we have 1 and 2, those two triangles. So the area of the first one, this is a right angle triangle, so this is basically a half of rectangle, so it's a half of h times p, and a2, it's a half of q times h. And as you can see, if we add up a1 and a2, we're going to end up at the same area of the whole triangle. So that means a must be equal to a1 plus a2, right? And now let's see what's happening. Well, a is a half ab sine of phi plus gamma, and that should be equal to a half h times p plus a half h times q. And now we're dividing it by a half AB, all right? So what do we have now? On the left-hand side, we have AB sine of phi plus gamma equals to, well, a half is, oh, my bad. I'm not having AB anymore since I'm dividing by AB. So I only have sine phi of plus gamma. On the left-hand side, I don't have a half anymore. I have h times p divided over a times p plus h times q divided over a times b. All right? And now let's see what it means actually. So let's write it the right-hand side, let's prolong it, and let's write it separately in order to see what's happening. Well, if we are considering, for example, this first fraction, we can write it as h divided by a times p divided by b plus, what do we have here? Well, here we can also interchange the order of the multiplication. It's going to be maybe q divided by a and h divided by b. Can I do it? Well, that's fine. What is h divided by a? Look at this triangle. H divided by a. Considering the angle of phi, its cosine of phi, right, is adjacent over the longest, and p divided by b is the sine of gamma. And what about q divided by a? It's an opposite divided by the longest, so it's a sine of phi. And what is h divided by b? Well, it's a cosine of gamma. And isn't that the formula we wanted to prove? Well, there you go. The first formula is done. Okay, that wasn't hard. Okay, you must prepare something like formula of the area of parallelogram, and then just do some maybe fancy looking stuff, but at the end mathematics is always about, is it valid or is it not? And it was valid. If you see it's not valid, please let me know. All right, move on. What do we have? Well, the second formula is just an application of the first one. Why? Well, we're just writing sine of alpha minus beta as sine of alpha plus minus beta, and we just apply the formula we previously proved, which means we have the sine of the first angle times the cosine of the second one, which is minus beta in this case, plus the sine of the second one times the cosine of the first. And now if you remember, we proved that the sine is an odd function and the cosine is an even function. So that means cosine is killing the minus inside and the sine is putting it through. So that means we are having sine of alpha, cosine of beta. No changes here because this minus is gone because cosine is an even function. But this minus is shooting in front. So we have minus cosine alpha and sine of beta. And now you see this is exactly the formula number 2, which we wanted to prove. Number 3, what do we have here? Well, number 3 is, if we're talking about cosine of alpha, you remember it's the same as sine of 90 degrees minus alpha. So if we're talking about the cosine of alpha plus beta, it's the same as the sine of 90 degrees minus alpha plus beta. All right? And that would be the sine of 90 degrees minus alpha and minus beta. And now I can put 90 minus alpha into parentheses. How would that help me? Well, I have the sine of the first one, formula number 2, that we previously proved, times the cosine of the second one, and then we had minus the sine of the second one, beta, times the cosine of the first one. All right. Sine of 90 minus alpha is just cosine alpha, so we got cosine alpha, cosine beta, and cosine of 90 minus alpha is just sine of alpha. So we have minus sine of alpha, sine of beta. Simple as that. That's the third formula. As you can see, totally the same we've been predicting. And the fourth one is also easily computed because we have the cosine of alpha plus beta. We don't know the formula for the plus, for the minus, but we already know the formula for the plus. So we have the minus here. We just write it as the cosine of alpha plus, well, the same, minus beta. And now we do apply the formula number 3. It's cosine of the first angle times the cosine of the second minus the sine of the first times the sine of the second. Now once again, cosine is even, so the minus is gone. We get cosine alpha, cosine beta. Sine is odd, so we're kicking it out. And since we have one minus already in front, it's becoming plus. So plus sine of alpha and sine of beta. As you can see, everything is proved. And I thank you for watching the video. Stay tuned. See you guys in the next video soon. Bye-bye.